That's Duke. All right, that's the official mascot of the Java programming language. So he's hovering over the city and waving hi. All right. Java is C++ without guns, knives, and clubs. I love this. Even Brian Getz, who is one of the Java architects, okay, for Oracle, used this in a presentation. We didn't even coordinate that. And when I saw that there, I laughed, because he actually used it. So this is James Gosling, who's considered the father of Java programming language. And I love this. And then the reason why is because one of the main reasons why is there's no memory management in Java. You don't have to take care of that. All right. So in case some of you were here last time, some of you weren't, so I will reintroduce myself. My name is Michael Redlick. I am a Java champion. A lot has changed since I was here last year. And I was named the Java champion in April of last year. I've been the lead Java Q news editor for InfoQ, which is a news periodical for IT stuff. I help out Pyara as a contract developer advocate and a technical writer. I'm the only US-based person that is here to do these kinds of things for them. I've known them for quite some time. The Garden State Java User Group, our logo right there. And so we've been around since 2001. We have our meetings in Madison, New Jersey. And then I'm in the Leadership Council of the Jakarta EE Ambassadors. And this is just a small group of folks, homegrown stuff, to advocate for the Jakarta EE framework, the platform itself. And this is the enterprise edition of Java. There's a whole history with that too. And I'm a committer on the Jakarta NoSQL and Jakarta data specifications. And I retired from Exxon last year after 33.5 years of service. So everything right here is what I do full time these days. All right, so objectives. What is Java? The evolution of Java, some features of Java, a quick review of OOP, which was actually more spelled out in the last session. All right. Also want to get started with Java, and then some live demos and some resources. So we got a fun, full, packed hour of stuff. So, and we have until 12:15. All right, so this is another quote from Sun Microsystems. This is early on to what describes Java as simple, object-oriented, distributed, interpreted, robust, secure, architecture neutral, which is true, portable, high-performance, multi-threaded dynamic language. That's a mouthful. So, and of course, Java has been around since 1995. So, I mentioned James Gosling, who had that great quote. Patrick Norton was another one of the Sun Microsystems engineers. So Java was started with Sun, and Sun got purchased by Oracle in 2010. In 1991, so what's that, 33 years ago, he originally called it Oak, and this is it's not a myth, it's a urban legend, but I think it's pretty much true. However, I think Oak was used for something else, so trade name-wise, it couldn't be used. The idea was to have it in consumer applications. It had to be architecture agnostic because of the fact that it was going to be in different applications, and they required it to be object-oriented. Now, of course, C++ has been around, right, since maybe around 85. I know C was around before that. So object-oriented was, a big thing, right? Still is, right? In 1994, there was this Project Star 7, which was this remote control, I think, project. But shortly thereafter, Java was introduced to the IT world in 1995 at the Sun World Conference, and there was also this hot Java browser. And I remember this because I'm old, right? So I remember this coming, being around and playing with it a little bit. A few years ago, I did find source code for it. It didn't work all that well, So I don't know if I can still get it now. I'd have to try to find that again. But of course, everybody's using Chrome and Firefox these days, right? But that that was a big thing back then. All right, features of Java. It's, as mentioned, object-oriented. I love the documentation generator for it. All you have to do is add comments in a certain way, and then you run this Java doc file or Java doc utility, and it basically writes things out with the same way as your normal Java documentation. There used to be these applets, and then a lot of people remember Java having these cute applets. You know, that Duke, you know, the tumbling Duke was the, you know, you'd see him tumble across the screen, right? And there were others, right? But then they had applications too, right? So similar to C++, it has comprehensive exception handling. Actually, it's more refined than the C++ exception handling. Java database connectivity was a big thing, still is, but now you have more of these frameworks to do different kinds of connections to databases, like for NoSQL databases, right? For MongoDB and so on. Java Beans was a big thing. They called them plain old Java objects. And this was a way to actually have, this is more like a properties thing. And you would have all these different attributes as part of your bean. And it also had to be able to be serialized. And then there were getters and setters that had to be formatted in a certain way. I think I get into that. Records and sealed classes are new. Records throws out that whole paradigm of the getters and setters in Java Beans. You don't do that anymore, right? And they're immutable by default. So that's a whole other thing. I don't have an example, but it's easy enough to explain. Enterprise Java Beans, I crossed out Beans. EJBs has, for the most part, been deprecated. It's not even in the, it's still a specification in Jakarta Enterprise Edition. And most important, there's no pointers. So the core dumps are kind of a, well, I don't want to say a thing of the past, but you know, you can't get those more as easily as you could with C. All right, here's Rodney again. Any questions so far? Okay. All right, I'm going to, hello, welcome. We just got started. All right, so just going to do a quick review from the last session. You know, the slides for the other, you know, for this talk and for the previous one are on my website. So Java it's a programming paradigm. It's object-oriented programming. Then the four main attributes are encapsulation, abstraction, inheritance, and polymorphism. An abstract data type is a user-defined data type, and you would define, or it's a use of objects through methods without knowing the internal representation. I like to use the analogy of a manual transmission. Unless you're a mechanic, you know how to use the clutch and the shifter, but you don't know how everything happens in that manual transmission. So that's sort of that internal representation. All right, an interface or methods that are provided that allow access to data. So you, the developer, you know, control who has access to what. And the implementation itself is the underlying data structure and business logic within an abstract data type. And then I will say, I showed this in the last session, interface and implementation are also keywords in the Java programming language to have an interface that declares methods. So if you have a method named Fred and it's just declared, then when you implement that interface, you would have to define Fred with a body of some kind, right? Is there anybody named Fred here? No, okay. That was a habit I got a long time ago from somebody else who used that. All right, and then the differences between a class and an object. All right, a class will define a model. It declares the attributes and behavior. Okay, so objects have both of those, right? It's an abstract data type. Now an object, now your class is live. And it's an instance of the class as it's referred. And because it's live, it has state and it has behavior. And you can have many unique objects of that same class. So you can have a, you know, car, Buick 01, and then define that. And then you can have car Buick 02. So you can have multiple instances of that same class. And then the advantages of object-oriented programming, basically the interface can and should remain unchanged if you're improving the implementation. So imagine me having the greatest linked list that I provide for to the Java community, right? And I have documentation that says, here's how you add an element, here's how you, how you sort and all those things. So you go ahead and use it in your client code. And you send me all kinds of great emails saying, oh, this is the best thing I've ever used, right? So, and then 6 months down the road, I say, I bet you I can make this thing twice as fast if. Now that's changing the implementation. But if I change the way you would add elements and sort elements, what happens to all your client code? If I, make method names differently, do things like that, does it blow it up? You'll have to edit all your client code to match what I had. Now I'm going to get emails that are yelling at me and whatever, right? So you don't want to do that. You want to keep everything the same. All right, and because because of all this, it encourages modularity. If you look at the source code that I have on, you'll see that they're very short, they're easy to maintain. All right. All right, so now we got that out of the way. Right? So, like I said, more details in the other presentation, which I have available online. Some Java keywords here. Class, of course, right? You need that. There's new. These are access specifiers: private, protected, public, and package. And then these are exception handling. So the try, throw, catch, and finally. And then there's a final keyword, which makes that particular element or attribute, immutable. Extends will create that relationship between a base class and a derived class. So class Buick extends car. Car is the base class, right? Implements is the keyword that will have class Buick implements a car interface, right? Abstract will, define an abstract class, and yes, interface is the way you could use in place of class to define an interface. All right, classes. It's a user-defined abstract data type. Okay, anybody know C programming? Anybody? Ah, very good. Oh, you know C? Okay. I know a bit. Do they teach C at school anymore? Or are you using like Python and stuff like that? Yeah. Python? Yeah, that's what I figured. Yeah. How about Java? Any Java? Not yet. Okay. All right. Cool. I know it's still being taught too. So I know I took the time to learn Python too. So it's pretty fun. So anyway, yeah. So you would have a constructor in a Java class. And then if you were at the last session, you will see that I had destructor, but that was for the C++ work. So you don't have to worry about memory management in Java, where it was everything you needed to do in C++. And then you would find your attributes or data members and member functions, or what they know as methods. All right, so then there's ways to instantiate. It's only dynamic in the Java world. You can have more than one constructor. So I like to refer to this one with an empty set of parameters as a default constructor. So when I define that, I would pretty much maybe have whatever values you're modeling. You can have some default values. I find that useful, at least for me. And then a constructor that takes in a string and 2 integers. And in this case, it's going to represent a team name and the number of wins and the number of losses. Then you can have in there a winning percentage that you would calculate based on those numbers, of those 2 numbers that get passed in there. Abstract class is one that has one pure virtual member function in the C++ world, and then one abstract method in the Java world. And an abstract method basically is something where you said have the method name, and then it's just empty. It's just there's no definition to it. The way you would set these up, this is C++. This was presented this in the last session too, has this bizarre syntax of assigning this function signature to 0. And then you would use the abstract keyword in the Java space. Okay, this is a hierarchy of a model of like an application, a sports application. So your sports will be the base class, okay? You can do the interface thing too, but this is just inheritance. So baseball, football, and basketball are all derived classes or children classes, if you will. But because it's inheritance, just like, parent and child, baseball, football, and basketball has all those attributes that are defined up in the sports base class. But notice, football and basketball, they'll have a tie, because in baseball, they don't have ties. They play as long as they need until somebody wins. The exciting walk-off home run, those kinds of things, right? So football and basketball have all that, but you can add attributes to tailor your application. That's a beautiful thing, All right, so I like this chart. This was, where was that from? Codejava.net. Okay. So I think this is great. This really decomposes a typical hello world. When you learn a new programming language, right? The first thing you do is write a hello world. So you can see here, all right, public is the access specifier. This is a class. And here's where you want to do an interface keyword if you want the interface instead of the class. This is the class name, all right? It can be whatever you want, of course. And then this is this is the entry point to an application. Now it's public, static, void. It's a void return type, it is static, and it's public, and that's always main. And you have a args variable that returns an array of string, and this is for like command line parameters. However, I don't know if it's fine, I have to remind myself, there is a way to simplify all this, especially for people new, where you can collapse all this to void main empty parameter list. All right, this is something that's new in the Java space. Trying to remember if it was in preview mode or if it's final. I'd have to look that up. And then system.out.println is a way to display stuff on the terminal window. Okay. So yeah, pretty simple. This is how you get started. And then you would instantiate classes and all that. Hello, how are you? Come on in. So. The beer's in the corner over there. Oh, sorry. This is good class. I wish I could, but anyway. All right, so let's do. This is a partial listing of that hierarchy I showed earlier. I do have, if we have time, I can show you the application I have. So here is public class sports. Okay, and what I'm going to do is, again, it's a partial listing. I have a team name and the number of wins. All right, so then this is a constructor. It's public and it has the name of the class, and that wasn't me this time. The phone rang with me. That's okay. No worries. No, you should have seen the last class. I had all kinds of technical issues. So, and then in this case, sports, the second constructor, I like to call it a primary constructor. It takes, all this stuff, the team name, number of wins, number of losses. So you gotta have, you gotta provide the types too, the data types. And then this is part of a Java bean, okay? Now it's not a full Java bean because there's other things that are missing, but the basic structure of a method to make this a bean is to have the get as a preceding the actual win that you see there, but the W is capitalized. And the same thing for the setters. So set win would be the same thing. All right. And then simple, in this case, you just return the value assigned to that particular variable. All right. So again, modular, I talked about modularity. A lot of these getters and setters are only 1, 2, 3, 4 lines tops, easy to maintain. All right, so then now our derived classes. Baseball, we have here in this case, it extends sports. That's that relationship between parent and child. And again, the class names or the constructors are the same as the name of the class in this case. All right. And now there's a way you can use the base class. You can have, there's a super keyword, or it's a super method, super and then empty parens, or super and the variables you want to pass in. That says, please use my parent to construct my baseball class. All right, just a simple shorthand, right? Nice little feature. All right, so in this case, when you want to create a new a Mets, or an object, it should be an object, right? Because it's so just like int I, or whatever, or bool true, same thing. Name of the class and the variable. But we're going to create that live method or a live class to say use the new keyword, the name of the class, and then pass in the values. I'll give you one guess who my favorite baseball team is. What gave that away?
I was guessing it was a game.
I have mutual respect for the Yankees, so that's.
Oh, you're a Mets fan.
That's right. There you go.
Oh.
Yeah. So this is how you would do that, right? Very simple. And deleting objects, basically you don't have to worry about it. Garbage collection takes care of the memory management for you. And there's a lot of work being done in the Java space on garbage collectors. There's the Z garbage collector, there's the G1, something like that, so G1, GC. There's a number of them out there. Java uses, I think by default, the hotspot garbage collector. But you can use this, the system thing like here. You can call the GC method, but it doesn't guarantee it's going to happen right away. So the garbage collector, there's an algorithm, the way it looks at things that are in memory in your application, what hasn't been used in quite a while, right? So it kind of organizes that, and then it deletes things after a number of time. So if it notices that, well, this piece of memory hasn't been used in the last 2 hours, let's say, I'm just making up numbers, then it'll wipe it clean. And so there's all this shifting going on with that. It's an interesting area to learn. And it's not as simple as at least I thought it was, as I got to learn a little bit about some of that. So it's quite interesting. All right, so the Java development kit, available from the Oracle website, but I still love using java.sun.com. All right, it still works, at least it did last time I checked, which was relatively recent, because Oracle bought out Sun in 2010 and took over, right, the JDK. So Java SE is the standard edition. Now, there was a Java EE. Anybody familiar with that history? The Enterprise Edition. When Oracle released Java EE 8 in 2017, they donated the whole Enterprise Edition to the Eclipse Foundation, and it was all open sourced. But because of branding rules, Eclipse Foundation had to change the name. So and this was a community thing. It was a community vote. People had a choice, or I think they originally had to submit ideas, and then there was a vote, and Jakarta was selected as the name for the Enterprise Edition. So that's why you saw earlier part of Jakarta NoSQL and Jakarta Data, those kinds of things. So yeah, it's great. It's community participation. It was closed source at one time, the Enterprise Edition, but there is the open source. Oracle still has their own proprietary that they have available, but then there's the Open JDK, which a lot of people have made their own downstream distribution, like Azul from Azul Zulu, Amazon Corretto, Bellsoft, Liberica. There are downstream distributions of OpenJDK with their own features. Those are the difference. Since JDK 9, which was around 2017, I want to say, there's been a 6-month release cycle. And the idea behind this is to have features in preview mode or incubating mode that you wouldn't want to use in production, but developers could experiment with them and provide feedback. So you'll see features for each release since JDK 9 that will say, feature name, paren preview, and then second preview. And then when they're happy, then it'll be finalized. So JDK 21, which was released last September. So the releases are March and September. That's why you see here the latest version will be released this coming Tuesday for 22. So virtual threads was one of the, one of the main features that was finalized. Went through a couple of iterations. Just as a side note, the vector API went through 7 incubations. Like there was incubation, second incubation, and I think this one in 22 or it was 21, there was a 7th incubation, but then all of a sudden they went back to normal incubation. I don't know why. Something happened there. I've got to try to find that out. So it's just weird. Like it's like they're starting from scratch. So I need to tap on the shoulder of some of my friends and see what's what there. All right. So next Tuesday, like I said, the latest will be out. I plan on having an InfoQ news piece on that. It might be out later in the day because the folks at Oracle are having this sort of release party. I'd like to report on that, right? So, all right. So enough of that. So set up on your workstation. All right. There's a Java _home environment variable that you can use. You can do it that way. So then a lot of applications look for that, right? So a lot of scripts that might execute whatever will actually look for the existence of that Java _home path. All right, source code. For those of you, anybody have used Java here? I meant to ask that earlier. Nobody. You said you haven't used Java yet. I forget your name. Have you used Java?
When I was in college, yes.
Okay, so you're familiar with some. Anybody who hasn't used Java? Okay.
Well, let's say getting started. Yeah.
Well, yeah, no, I know, but I want to get an idea of what, yeah. Okay, great. So source code will have the .java extension on it, right? I mean, some of the stuff, if you already know, then I can always, and then when you compile your source code, there's a .class extension. And this just creates bytecode. So it's not native executable, it's bytecode. And then it's interpreted by what's known as Java Virtual Machine. And there's a whole big development on JVMs as well out there. So IBM has their Eclipse J9. Can't think of any others at the moment, but there are a number of them out there. All right, when you compile a source code, I use an integrated development environment now. And I have to remind myself on how to, where to have my, what path that I need to be in order to run the Java, this runs the application. Java C is the compiler. Java doc is that, that tool I mentioned. If you format or have your comments above your methods and have them in a certain way, you run the Java doc utility on it, and it actually creates great documentation. So I can probably show you if we have some time at the end. All right, directory structures. I think this is important because a lot of projects out there, open source projects, will use this. All right, so you want to map directories with packaging. So you'll see if you look at open source stuff, right? Okay, so Project X, right, will have a source folder, and then under that will be main Java, right? And you can have it without this stuff, right? But then, if you want to be consistent with the rest of the world, as it were, you would want to have that. And then that's sort of like implied. And then under that, I continue with org/redlick/ the name of the project. That's just, for me. So, other companies will have IO/Helidon, for example, right? Because Helidon's a framework for microservices, and so on. So this is important. And then this is kind of like, I just mentioned that right there. So, so the package name, so once you have this structure here, right? So this is the path, Java apps, right? TCF, hello, all that. The package name on your source code will follow this, which is only here in green. This is assumed, right? Source name. I just realized I screwed that up. I have to fix that. All right. So where are we here? Live demo. Oh, okay. Yeah, we're in good shape. We can spend some time. All right. So I have, this is IntelliJ IDEA. These are integrated development environments. There's other ones, the Eclipse IDE, there's the Visual Code from Microsoft. But I find this as a favorite. I pay for a license on this. That's how much I like it. And my user group gives away a free license. JetBrains, who makes this stuff, they provide our user group with 1 license per month that we can raffle off at our meetings. And it's good for 1 year. Yeah. So, so this is our sports class that I had earlier. So we can get into more details on this. Now let's look at the, all right, so, okay. Okay, so, do I have Gradle here? Gradle, okay. These are build tools. Gradle and Maven are build tools. Let's just clean that up. Okay. Okay, and then let's do trees. All right, what I want to show you is that hierarchy, right? So the main, the root is, all this on my machine, user local presentations and so on. And then this is all the Gradle stuff. But then source name Java, that's what I wanted to show in the slide. But I think I missed a couple. It's amazing what you catch when you deliver the presentation, not when you're putting them together. This has happened to me many times. So anyway, then I have the org Redlick sports. So other projects I'll have, that name will be something else, right? So, and then under that, this is the source code. So I have baseball, basketball, football, right, and so on. Usually sports app denotes like sort of this is the entry point of the application, right? So you know the stuff like I've shown before. Sports is a base class. Baseball, basketball, football, and hockey are derived classes or children classes. So we can look at them, right? Let's see. So, some of these are open already. Okay. So let's look at sports first. So this is our, let's see, this is our base class. Now you notice here, and it's highlighted in green because, syntax highlighting is awesome in IntelliJ and then others, right? So it says here default constructor. You notice I have slash and then 2 asterisks. Because if I took the 1 out, it'll change color, right? So basically this tells me, hey, this is my default constructor. And then when you run it through JavaDoc, it actually, writes all that out. So let's see, beginning here. All right, so public, so here's the package name. And again, it's just everything after the Java folder. And then you have imports. So if you want to import different libraries, you can do that as well. And you can set up dependencies in Gradle or in Maven if you want to import all that stuff. So, for example, I don't have anything, no dependencies here, but you would define them in here. All right. This is a Gradle file, build.gradle file. In our sports class, so you have here's everything that I'm representing. The team name, the wins, losses, the tie, which I think I have a better example without that, but just ignore that for now. So, yeah, so in my default constructor, I'm using setter methods to provide default values. Some generic verbiage of team, and then set wins everything to 0. My primary constructor, now I'm passing in all these various things. Okay. You notice here I have @return team, but I shouldn't have a description, I should have like the team name or something like that. So this is a get team. And again, as I mentioned earlier, like get win, team is the attribute itself is TEAM lowercase t, but the getter is get team uppercase T. And so on and so forth for everything else, right? here is a setter for that set team. It accepts a string with the team name, and then it uses this keyword. So this dot team refers to, because it's being assigned, it's on the left-hand side of the assignment, refers to the variable here. So it's nice shorthand with, by using the same name. All right, and then this team name corresponds to this one. And so on, everything else, right? Getters and setters for everything. The set percentage does the calculation, right? So, and then it makes sure we're not going to divide by 0, so we don't have a runtime error. Those are not good. And here's our display. All right, so there's some formatting stuff in Java you can use, decimal format, so you can have 3 places after the decimal point, and then have a preceding 0 if you need it, for a single number. And then this is system.out.println, and then you can pass in all this stuff to print it out on the screen. Oh, and there's this toString method. That basically is a way of saying you can define that as well. And inside there's some default output. And I guess I meant to do that. And I think what I'll do is, and this is a cool feature too in IntelliJ, you do it changed the color, right? So add a more refined toString. Right, there you go. Okay, so, and if you have a whole bunch of these, how do you find them? Well, you go to here where it says do, and then it puts them there for you. So, and it takes you there. So this is cool. This is I don't know if the others do this or not. It can also do as fix me, right? So you can do that as well instead of a to do. So let's look at some of the other stuff here. Here's baseball. It's going to look very much the same, right? We're importing the decimal format now. We showed that. Okay. Oh, here's that super method that I said. So in our default constructor, right, I say, go to super, go to my parent, please, and then implement that. And the same thing here, super, and then you pass in all the variables that are being defined here. Okay. It still creates a baseball class, but it's using the base class as that. Now, here's the difference. This is a somewhat small example of polymorphism. We have a display method. And the other ones like basketball and hockey and all of them have the same thing. Only difference is we're not going to display the tie in this case because there are no ties in baseball, right? There's no crying in baseball. There's no ties in baseball. So sorry, I couldn't help myself on that one. A League of Their Own, anybody? Anybody? Okay. So, yeah, so that's that. So in basketball, pretty much this is football. Yeah, same thing. Oh, okay. Yes, very important. There's no display method here. And why is that? What does football have? What does it inherit?
Programming or
Yeah, I don't have a display method defined here. Because
yes.
Yep. The base class.
Base.
Yeah. Yeah, so that's exactly what's happening here. I didn't have to define a display method because it's using the one from its parent. So, so that's the difference there. Now I think I have another similar application where I put in, I don't have the tie in the base class, but I added in the other child classes. Yeah. So, but yeah, so that's an idea of how that works. The sports app. I'm going to create a new instance of sports app and give it the variable. So this is again like I showed in the slides. Sports app, or like baseball, or baseball Mets equals new. All right, the same thing here. I have a display header method that just puts out this sort of banner. If I had the time, I'd love to do some ASCII art, but who's got time? So this is programming to interfaces and not concrete classes. I'm defining the New York Mets variable as type sports because baseball is a sport because of the inheritance. It has that is-of relationship. So I can do that, right? And then basically this display method, because it's the Mets, it will use the display method that I defined in baseball without the tie. And then, and the same thing here, New Orleans Saints, right? They weren't 13-3 this year, but that's okay. And then Devils, you know, all that, right? So I'm using the display method for the other ones. So, all right, so let's run this. Good. All right, so not MDN, grading. We'll clean it and then we'll run it. Okay, so very simple. I mean, it was pretty quick. So you see what's put on the screen. It's Mets 97-65, and then a winning percentage. But then Saints, Devils, and Nets, you'll see that there's a third digit. There's the Saints 13-3-0, Devils 47-32-3, and then it calculates the winning percentage based, you know, having that extra value of a tie incorporated into the winning percentage. So yeah, so you can see how well it works, right? Now, of course, I get this output saying deprecated Gradle features were used in this build. Gradle's gone through a lot of change. That there's some older source code that I, you know, where the build file itself is like a lot of it's been outdated and it won't even run because you have to update it. So I've been doing that little by little in here. I use Maven quite a bit more. There is a Maven is probably twice as popular as Gradle. You'll probably see a lot of open source using Maven. There are some like Micronaut is a framework for microservices. They use Gradle explicitly, so that's the, you know, that's their thing. So it's worth learning both. But like I said, there's been a lot more change in the way Gradle does things than Maven itself. Maven is a very powerful tool. There's plugins you can use to automatically run, you know, to automatically run the Java doc. I think we'll run this through here actually. How do we use it again? Let's see. No. Oh, I know. Oh, hold on a second. Let's see. Source. Oops. Main Java Word. Sports. Star.java. Okay. Okay. There's some. Oh. Okay. I have some errors here. That didn't work too well, did it? Oh, I know why. It doesn't like the. It doesn't like the text block. This is a new feature here known as text blocks in Java. So, but I'm surprised it doesn't like that. So, okay, well, we'll have to skip that for now.
So I'm sorry.
Yeah.
How were you able to figure that out? Like,
Oh, I had the three quotes right here. Yeah, that was one thing, and then it was expecting, I guess, the normal closing of statements. You know, it had it right here. Welcome to the sports demo. It's not a statement, etc. So I don't know why that is. Yeah. So I've been trying to implement some new features, and this is what happens, right? Yeah. But what it would look like is, I wanted to show that to you as well. Can't get to the browser here. There we go. Let's see. The JDK, oops. Okay, and then Java 22. All right, so this is what it looks like here. So if you want to find, no, I don't know, vector, is there a vector? Yeah, Java util vector. Okay, it gives you, so the output, when you run your source code through JavaDoc, it will actually output everything like this. So a lot of the comments you have in there, like it had @return, and then, you know, what the return type is and maybe a description. So these are the kinds of things that you can do. I was running a project, which is 12:06, so we should get near the end here. Yeah, yeah, but this is, like I said, it's a very powerful tool, I think, for describing, for putting documentation out there. Really cool. So, all right. Any questions on that source code at all? Anything? You can always send me email afterwards. So, all right. So where do we want to go? Here again. Okay. All right, so Java IDEs. What I showed you just now is IntelliJ IDEA. It's about, I want to say, $80 a year. But you might get a chance to win a one-year license if you come to one of my user group meetings. So, there's the Eclipse IDE, which I mentioned. Microsoft Visual Studio Code. I've seen some of my friends use this. It's quite nice from what I've seen of it. And Apache NetBeans has been around a long time. That got open source too. That was once owned by Oracle, and then it got donated to the Apache Software Foundation, as opposed to the Eclipse Software Foundation. And so that one's, I've used it before. Interesting fact, James Gosling, the father of Java, actually prefers NetBeans over anything else. So, local Java user group. So I mentioned the Garden State Java user group, and that's our, like I said, that's our logo right here. We've been around since 2001, although the first 19 years was under a different name. We rebranded. I think I mentioned that earlier. We're on our own nonprofit. And so the leadership team is myself, three of my friends, Barry Bird being one of them here, and two others. And we have some other leaders that help us out with logistics. The New York Java SIG has been around since 1996. This is one of the oldest, maybe even first Java user groups out there. Frank Greco, who's the main lead on that, has been at TCF. That's when I first met him. So we go back a bit. And one of the things we've been doing, along with the Philly Java user group, we've been getting speakers. If they come out for a week, let's say, they can hit all three of us in 1 week. And so we've been doing that recently. And I'm just working on getting Marcus Helberg in September to come visit with us. So it saves on expenses if they're in the tri-state area for a week, and then they can hit all three of us. It's just a win-win. The Capital District Java Developer Network was around a while, and then the facilitator moved out west. They shut it down, but they're looking to get back up again. I went up to speak with them a couple of times. They're a nice little bunch of, nice bunch of folks. So it's nice to see Albany or Troy. They moved around their venues a little bit, but so it's good to see upstate New York. Then further reading. Barry Bird is here giving talks. I think he gave that crazy keyboards one, if anybody went to that. So yeah, so he has the Java team. Is that right now? Okay. Yeah. I think I twisted his arm to be here at the end after Chuck Knight's 2 Python talks. I will be here at the end for an Ask Me Anything session. So ask us anything about Java, Python, what we do, what we hate, what we like, so, so that will be at the last session of the day. But Barry is, Barry started coming to the ACG&J Java group, which was the previous name. We met in Scotch Plains back then. And he came around 2003, and then he's been a regular ever since. So he's one of the co-directors. So once we went, so I've known Barry for over 20 years now. Head First Java, I mentioned in the last session, the Head First series of books. These are outstanding. If you ever thumb through one of them in the bookstore, you'll see their use of pictures, their source code. It's just so easy to digest and learn from those books. I mean, it's just the design patterns one is the one I have. I don't know if I have that one. I may have one or two others, but I highly recommend these. So, and I think this is, I have to ask Barry himself, if you see him around, what his latest edition is.